Section 4.5, Part G. Use slopes to identify perpendicular lines. Now these perpendicular lines are in the same plane and form right angles. Theorem. Given two lines y equals m1x plus b1 and y equals m2x at b2, here the subscripts are telling us that the m's are different from each other and so are the b's. Given these two lines, the following are four equivalent statements. Their graphs are perpendicular. m1 times m2 equals -1. m1 is the negative reciprocal of m2. m2 is the negative reciprocal of m1. Example 28. Determine which of the lines in this GeoGebra activity are perpendicular. Line F, y equals 3/2 x minus 2, has slope 3/2. To find a perpendicular line, we need to see if any of these other lines have a slope -2/3, and it appears that this line does. And when we graph them, we see that they are indeed perpendicular to each other. Here, line G, y equals -3x plus 1, we need to see if there is another line that has slope +1/3. Although these two lines have slopes that are reciprocals of each other, they are not negative reciprocals of each other. In fact, there is no perpendicular line to line G or H. And finally, line Q and R. It appears if we were to multiply the slopes of both of these, -1/2 times 2, we would result in -1. And indeed, these two lines are perpendicular to each other. In example 29, we need to determine if these two lines are perpendicular. We can do this by writing both of them in y equals mx plus b form to determine what their slopes are. My first equation becomes -2y equals -3x plus 5. Divide both sides by -2. My second equation, I'm going to add 4x to both sides. And then divide both sides by 6. Now I can see, once I simplify, that this equation and that equation both have positive slope, so that they could not be perpendicular to each other. These two equations, once we solve for y, turn out to be y equals 3/2 x minus 5/2 and y equals 2/3 x plus 1/3. When we multiply the slopes together, 3/2 times 2/3, we result in 1, not -1. Therefore, these two lines are not perpendicular to each other. You try 46. Find two lines that are perpendicular. The first line has slope 2. Is there a -1/2 slope in any of the others? No. The second line has slope 1/2. The negative reciprocal of 1/2 would be -2, which occurs here as a slope. Therefore, my second and third equation are perpendicular to each other. Now, any vertical line is perpendicular to any other horizontal line, and every horizontal line is perpendicular to every other vertical line. And you try 47, find two lines that are perpendicular, find two lines that are parallel, and find two lines that are identical. Once we simplify these equations and solve for the variable, we notice that my first two equations are the same. So these are identical lines. The second and third are a pair of perpendicular lines, and my last two lines are parallel to each other. You try 48. Find two lines that are perpendicular, find two lines that are parallel, and find two lines that are none of these. My first equation is perpendicular to the third equation because its slope, when we take the negative reciprocal, would be negative 1/3. The second and third equation are neither parallel nor perpendicular because they do not have the same slope and their slopes are not negative reciprocals of each other. The third and fourth equation are parallel to each other because they have the same slope, negative 1/3. And they are not identical because these two lines have different y-intercepts, 5 and negative 4.